Hello and welcome to my third tutorial. This is Casey, and in this video we are going to look at partial fraction decomposition of irreducible quadratic factors. The vocabularies and terminologies are just scary, but the good thing in math, we have a solution for everything. Well, in the previous videos we saw that when factoring a proper rational expression, the only thing on top of the denominator, or rather the numerator, of a linear factor is a constant. Meaning, every linear factor in the denominator, you will need a constant in over that at the numerator. So, example, x over x plus 1. Remember, x plus 1 is a linear factor in the sense that if I solve for x, I get x is equal to -1. Okay? Now, if I was to decompose this fraction as an example, what all I'll do is I must have the numerator has to be a constant, which we've seen in the previous example is equals to a. Right? Now, how about irreducible quadratic factors? First of all, irreducible quadratic factor is a factor that is quadratic. I will explain. Or that has a highest exponent of 2. Example, we have x squared plus 2. Okay, this is our irreducible quadratic factor. Why? The reason for this is because if we factor, we get a quadratic factor that has no real numbers that make it equal to 0. Well, let's solve it. If x plus 2 equals to 0, then x squared is equals to -2, hence x is equals to the square root of -2. And that's why it's irreducible. Therefore, if x squared plus 2 is equals to 0, then x is equals to the square root of -2. If I was to graph this equation, you'll notice that the graph does not cross the x-axis. This is x and y. Right. So, what do we do when we have irreducible quadratic factors and we want to do fractional decomposition? This is how we do it. Suppose we use the same example, x over x squared plus 2. What we have to assign, our denominator remains the same, x squared plus 2. However, the numerator is going to be ax plus b. Okay? So, for every irreducible factor in the denominator, which is this value here, you will need a linear term and a constant in the numerator. Therefore, before you proceed in doing any calculations, you have to consider that what are the denominators in your equation. If it's an irreducible quadratic factor, these are the considerations you need to make. In my next tutorial, I will work out on an example on how to solve such problems. Once again, thank you for your time.